So today we're diving into a really cool new AI model that's basically teaching computers to see the world a lot less like a machine and way more like a person. It's called VL-JPA, and it's built on a super simple but really powerful idea. What if an AI didn't have to get bogged down describing every little detail, but could just understand the meaning of what it sees? Okay, so to really get why this is such a game changer, we first got to talk about the huge wall that even our most powerful AI vision models keep smacking into. The top tier AI we have today, we call them vision language models, or VLMs. They're amazing at the stuff on the left. You show them a photo, they can describe it with incredible detail. But the moment you ask them to do the stuff on the right, like watch a live video or help a robot navigate the real world, they just hit a brick wall. And the problem is simple. They're just way too slow. And there are two big reasons for this. First off, training these models to be such perfectionists is insanely expensive. It just eats up a ton of computing power. And second, and this is the real killer for performance, they generate text one little piece at a time, predicting every single word. That whole process creates a massive lag, which makes any kind of real-time reaction totally impossible. So this got the researchers at Metafair thinking. They asked this brilliant question. What if, instead of predicting the exact words to describe a scene, an AI could just predict the meaning behind it? And that right there is the idea that changes the whole game. This slide has the perfect analogy for this. Think of a typical VLM like a stenographer in a courtroom. They're meticulously writing down every single word. But VL-JPA, it's more like a journalist. It's not obsessed with the exact phrasing. Its main goal is to capture the essence, the core idea of the story. It's all about the what, not the how you say it. And that essence is captured in something called a semantic embedding. The best way to think about it is like a unique GPS coordinate for a concept inside the AI's brain. So words like dog, puppy, and canine would all have coordinates that are super close to each other, while a word like car would be on a totally different continent. You can see how predicting that one little coordinate of meaning is so much more efficient than having to spell out DOG. So how does this actually work under the hood? Well, it's all thanks to a brand new model design called the Joint Embedding Predictive Architecture, or JEPA for short. The whole system has four main parts that work together in a really clever way. First, the X-Encoder looks at an image and kind of squishes it down into the important bits. At the same time, the Y-Encoder takes the correct text description and figures out its core meaning, that semantic embedding we were just talking about. Now, the Predictor is the real brain of the operation. Its only job is to learn how to connect that compressed image to that core meaning. And finally, you've got a lightweight little Y-Decoder that can turn that meaning back into words. And this is absolutely crucial, it only does it when we actually need it to. Now, I know this diagram looks a little complicated, but the magic is happening right in the middle. The model takes in the visual stuff on the left and the text stuff on the right, and its entire goal during training is to get its prediction of the meaning to perfectly match the actual meaning of the text. It's learning to connect what it sees with a concept, completely bypassing that slow, tedious process of generating a whole sentence word by word. And that separation of understanding from text generation, that's the secret to its incredible speed. So the million-dollar question, does this fancy new approach actually deliver better results? Well, the researchers put it to the test, and let me tell you, the data is pretty convincing. And wow, the results really do speak for themselves. In this head-to-head test, VL-JEPA is the blue line, and the old-school model is the red line. On the left, you're looking at video captioning accuracy, and on the right, video classification. In both cases, as the models learn more and more, that blue line for VL-JEPA just climbs higher and faster. So it's not just better, it's actually learning more efficiently. And here's the real kicker. The traditional VLM they tested against had about 1 billion trainable parameters. Those are the knobs the AI can tune to learn. But VL-JEPA, it only needed 500 million. Half. Yep, you heard that right. It delivered superior performance with 50% fewer parameters. It's just flat-out proof that teaching an AI to predict meaning isn't just a neat trick. It's a fundamentally more efficient way for it to learn about our world. Okay, so this massive gain in efficiency isn't just about saving some cash on server costs. This is the key that unlocks a capability that has been pretty much out of reach for powerful AI. Understanding and reacting to the world as it happens in real time. And the secret sauce here, the way it achieves this incredible speed, is through a clever feature the researchers have dubbed selective decoding. So check this out. Instead of constantly spitting out words, VL-JEPA just outputs this continuous stream of meaning. It can simply monitor that stream, and it only triggers the expensive process of actually generating words when it notices a big change in meaning. Like when a person in a video starts a totally new action. It doesn't waste its breath describing something that isn't changing. And this smart approach, it's unbelievably efficient. In their tests, it led to almost 3 times fewer decoding operations compared to a model that just constantly babbles on about everything. And it did this without sacrificing any performance. It's literally working smarter, not harder.
So, what does this all mean for us, for the future? Well, this leap in efficiency finally makes all those sci-fi applications feel real and practical. We're talking about smart glasses that can actually be your co-pilot for the world. We're talking about robots that can react instantly and safely to whatever is happening around them. Or, security systems that only ping you when something actually important happens, not just because the wind blew a leaf across the camera.
The researchers themselves summed it up perfectly. By focusing on the continuous space of meaning instead of the messy, clunky space of individual words, the model basically simplifies its own homework. It's just a smarter, more direct path to genuine understanding. So this shift from predicting words to predicting meaning, it's not just some small, incremental improvement. This is a fundamental change that closes the gap between AI living on a server somewhere and truly intelligent systems that can see, understand, and act right alongside us in the real world. It really makes you wonder, what's the first thing we're going to build with this?